start to talk to you about why we are interested in study pollution in Patagonia. Well, you may know that pollution, persistent organic pollutants are pretty special kind of pollutants that now, under the Stockholm Convention, as we heard yesterday from Rome, are a global concern. The problem is that the number of chemicals that have these POP properties, means persistence, long-range transport, bioaccumulation properties, etc., are increasing. Many of South American countries, including Chile and Brazil, are signatory countries for this Stockholm Convention that started with 12 chemicals, but now we are reaching 21 chemicals of very different, somehow different from the previous ones. And one of the problems we have here in this meeting is that data availability regarding the legacy POPs and these new POPs, even in the southern hemisphere, I'm not talking just about South America, but the southern hemisphere, is really scarce. So if we care on the global environment, we need to promote the gathering information from this part of the world too. And you may know that Patagonia, which is where this continent ends in the southern part of America, is an area of high sensitivity to change. You may know that, for instance, in the last 100 years, the retreat of glaciers reached up to more than 10 kilometers during the last 100 years. So the sensitivity of these ecosystems to this global change is pretty surprising. And this area also contains very unique ecosystems. But also, Patagonia is an area where human intervention is increasing. We have tourism there, a lot of tourists attracted by Torres del Paine National Park or other national parks in this area, but also some productive activities such as aquaculture, for instance, fish farming, forestry of exotic species, and also livestock. So, we started to work in Patagonia about 5 or 6 years ago, and our research questions were related to the occurrence of POPs in such remote areas. If the first was if POPs were present there, and the second one, where they came from. Given such research question, we started to study two kinds of pollutants. One related to PCBs that many of you are familiar with, the pollutant already, because they were forbidden in Chile at least in 1982, and the study of some emerging chemicals such as PDDEs that are still in use, but some restrictions may apply because they are now part of this new regulated by the Stockholm Convention. In both cases, uses are different. PCBs were used as dielectric fluids in transformers and condensers. Some other applications involve plastics, paintings, or building materials, and PCBs are used in many of our daily lives. We have already heard yesterday from Roland. So we started to work in Patagonia trying to understand what the levels of POPs were there, and we were starting to work on abiotic matrices. So we were sampling the sediments in lakes situated along environmental gradients. We tried to date these sediments using some radiometric measurement methods and some natural markers to try to reconstruct the positional fluxes of PCBs and PDDs. In addition, we have been performing some air passive sampling by using both POPs, polyurethane foam, and XAT2 samples. lakes environments are quite good for studying pollutants, since it's a kind of natural trap for pollutants transported by the atmosphere, but also by the drainage watershed. So many of the pollution arriving into these lakes coming from both atmospheric transport or transported through erosion or runoff process throughout the watershed. One of the interesting features in Patagonia is that in pretty short spatial scale, we have drastic change in environmental conditions. For instance, we have here a transect from west to east, and we find here a mountain areas on the seaside, and then a more dry area on the east side that corresponds to border with Argentina. So if you can see here the annual rainfall measurements, we have 3,000 millimeters of rain here, and we have only 600 millimeters here, less than 200 kilometers. So we have drastic change on some environmental variables like precipitation rates, even temperature, but also landscapes. So we try to capture this variability by take samples on lakes along this gradient. So we were in this area, in the central Patagonia area, we take sediment samples in different lakes located along this gradient. So coastal lakes where rainfall is around 3,000 millimeters, to lakes located in more highland areas where the precipitation rates are lower, but also temperature is lower. There's pretty small lakes that are pretty common in this kind of environments. We went into these lakes, we take the sampling, we do the sample by using a gravity cutter, kayak usually. We usually do some X-ray analysis of sediments, because if you find that your sediment is perturbed, you cannot use for reconstructing any pollution pattern or trend. And we have sampled so far more than 100 lakes, and only we have found very few lakes that are useful for reconstructing this pollution history in this remote environment. So we take samples along these 4 lakes. We're taking samples there. This is a sunny and nice days, but this is pretty unusual there because it's rainy and windy, and it's not actually easy to take samples. And then we took these sediments and we tried to measure pollution levels, in this case PCVs and PVDs, and try to calculate fluxes if these sediments allows dating. We were pretty lucky in this case because we find some small lines with X-ray analysis, and we found out that these lines are volcanic ash. And we fortunately have the date of those eruptions there. So besides the use of lead-to-term and cesium-137, we have also the possibility to use natural markers for controlling our dating. We are pretty sure that the dates that we have are in the right direction. We found here that this is PCVs, these are PVDs here, and we'll note that levels are quite low, of course, because this is a pretty remote area. But during the last time, we have here more or less 2000, or 1990, excuse me. It's starting to increase in 1990. And for PVDs, this is a sharp increase during the last few years in the top of the sediment core. And we find this more or less in the 3 sediment cores along this gradient, that there is an increase of PCVs above the detection limit on more or less 1990s, and the PCVs start to increase quite recently. So we know that PCVs increase since 19th and PVDs are more recent, but during the 90s that motivate this increase in pollution. We did some analysis looking at temperature relationship or temperature dependence, and we found this pretty nice relation between the levels of PCV28, a very light congener, around this gradient. So we note that in the coolest areas, concentration seems to be higher, which is corresponding with some temperature dependence process in the deposition of this pollution. And when we took our data and compare the levels with other lakes, such as on the lakes area far beyond the levels, even found that in some Arctic lakes, but our levels are comparable to the levels of PCVs found in pretty remote areas in the Arctic, which is quite. We have the Arctic lakes there, so we have the concentrations. When we look at fluxes, having the deposition rate, we may calculate fluxes of deposition rates. We are more or less here. There are data gathered from other lakes too, but we have our lakes here, and we are more or less in the same order of magnitude than other authors that have found in the Arctic. So the first good news is that lakes are polluted, but levels are pretty low still. However, the bad news is that they're increasing still. The other strategy we have been used is the use of passive air samplers, trying to get out some information regarding air concentrations of some POPs in this area. And we try to follow some valley to mountain scheme. So it is known that in the valley, low altitudes for volatilization, usually sources are more near the valley, and then there's a net mobilization of pollutants to altitudes that favors deposition of pollutants, to increase in rainfall and snowfall, and lower temperatures that may motivate that we may find higher concentrated highland areas. So we try to follow this scheme along a watershed in the central Patagonia area, the Rio Cisnes watershed. But the interesting thing is that this gradient follows more or less this pattern. So we have in this part from here mountains. The highest part of the basin is more or less located in this area, and the driest part of the basin is located in these three sites. We sample also urban site. Coyhaique is the main city in this region and is populated by more or less roughly 19,000 inhabitants. But the population density in this region is less than 0.8 inhabitants per square kilometer. So you may realize that there's almost nobody in this area. Anyway, after 1 year of deploying this XAV that are now in process, work together with the group of Frank, we deploy around this altitudinal gradient our samplers, and we know that we were able to detect both on the sulfur, which is on the top of the discussion with our Indian colleagues now, so that we know the pretty nice increase in concentrations along this gradient. Very low concentrations on the lindane, gamma HCH here. Alpha HCH was only detected in the highest part of the basin. But anyway, comparing this result with the urban site, it looks like the urban site has or presented very higher concentrations rather than this remote sites. Is this always true? Seems no. Because we also analyzed some PAHs, foreign PAHs in this case. Interestingly, we found higher levels of PAHs in these two sites and pretty much higher than in the human side. It was pretty surprising because in Kiyake there is a lot of biomass burning for heating purposes. And I was thinking before to see this result that the levels in Kiyake should be higher than we found in this. But one of the reasons of this difference may be that probably the pH that we are sampling with this system are not necessarily those more related with the biomass combustion. There's some past results too. We have done some analysis here. There's a 1-year deployed period of PAF samples, but you may remember from the presentation yesterday that PAF samples allows for a temporal resolution. So you might deploy it for 3 months, so you may have 4 samples per year, so you can reconstruct that temporal resolution. But the pattern we observe in the nearby Kiyake area is that in some case there is a pretty nice temporal changes. This is more or less summer, this is more winter, spring, and it is clear that in this case for endosylvan 1 levels are higher in winter and spring, and in other cases the opposite is true, like in cis-chlordane. So the patterns we have been finding so far are pretty complex. So we need some more information to try to capture what is actually happening in this type of samplers. So up to now we have this process of pollution there, which is pretty low. It reflects low anthropogenic impact. So we decide to move to the biotic component now. And one important feature of this region is that there's a lot of fish there. But in total, they are not native from there. They are all introduced fish. So we decide to move towards the analysis of this kind of fish, like salmons. So fish farming industry in Chile was competing face-to-face with Norway as a global leader on salmon of farm production. So this is Norway, and this is Chile. They were pretty near in 2005. But what happened was that in Chile there were some diseases affecting fish, and then the production falls up to, I think, now we are in the order of 500 tons, more or less. Yeah. But anyway, salmon farming continued to be a pretty important activity for this area compared to other regions of the world. So one of our first study we did was the concern on the salmon industry, because in 2004 appears a paper in the literature written by Ron Heitz in Science that, summarizing, say, well, we have both fish farmed salmon and we have wild salmon. And PAF's concentrations are much higher in fish farmed salmons than in wild salmon. In other words, this paper to the consumers, you have to choose at the supermarket between a farmed salmon and a wild salmon. Please choose the wild, because pollutant levels are lower. Okay, so the salmon industry in Chile got scared, of course, and they started to think, well, we don't have so much data. We need to gather some data on these pollutants in fish tissues, so we need to take care of that. And they were interested in some brominated plain vitamin at that time. And we did a study with them to take. We were allowed to take samples in different zones, including in the Patagonian southern area, of fish tissues to analyze the presence of brominated plain retardants. Surprisingly, results reveals pretty even different zones were taken into account, with pretty different geographical areas, the pattern of pollution that we observed in the fish tissue was rather similar. So we didn't observe difference in the brominated flame retardant pattern between these different regions. So we started to think that probably the origin or the source of this pollution may be some common. What have all these regions in common is the feed. So we analyzed also the feed, found a pretty interesting results of very nice correlation between the content of PVDs in the feed and the content of PVDs in the final product, which is the salmon tissue. So when we look at this result, we started to see that in Patagonia we have a series of problems with pollution due to fish farming. One of the problems we have there is that there's a lot of escapes from fish farms towards the nature. And then these escaped fish start to do a natural life cycling. So there were no data for this kind of pollutants in wild salmons in Patagonia. So we were looking at that, trying to figure it out what's happening with these pollutants, but in the wild. We started to think about this idea of biotransport, so that fish may act as vectors for transporting pollutants from fish farms towards clean rivers and lakes. So we have salmon escape from fish farms. We have a very active salmon industry in Chile. You may know that this starts usually on a small farm producing eggs, then growing these eggs into the fresh water, and then transferring the smolts into sea cages where they are growing. This is the amount of US 3,000 million US exporting fish from Chile. It's a big business. So we're trying to figure out how this activity could promote pollution. By looking at this, there's a figure taken out of a paper of Jules Blaise from the Ottawa. And we were trying to think, well, we have fish here that maybe are accumulating pollutants both through natural process or through anthropogenic process in fish farms. And then when they escape, they may transport this pollution towards rivers and lakes in this area. If you look at the amounts of escaped fish, it's scary. We have here two major salmon escapes phenomena in Patagonia. We have July 1st, 2004, 1 million escaping. In April 2007, during a earthquake there, 12 millions of salmon escaped from the fish farm industry. So if we think in these figures, it may turn out that pollution may be quite significant towards our rivers and lakes in such well, you know, we have this fish that is growing in farm, but for some natural reason like this earthquake in 2007, they may escape and start to do a kind of natural life cycle. So we try to go to the area and try to sample wild fish. And our first study was, this is a PhD student that is finishing now, was to sample Chinook salmon. Chinook is the largest species, which is not cultured there. So it's now performing a natural life cycle, but there's no culture of Chinook salmon. And we have these two rivers here, Remules and Nearby, well known for fishing, so there's a lot of tourists going there. So we profited them, and we talked with many U.S. and Canadian to take samples there, fishing, but also we to go fishing, and we had a lot of difficulties because this is the size of the fish, more or less, we were sampling. So it's about 1 meter long and 15 kilograms. And these two girls that were there need some help from local people. And we started to use nets, but they were quite difficult. At the end, we used this, how do you call it in Japan? We were there to take the samples and test them for PCBs and PVDs. So what we found in this study that we just published in March this year, we found PCBs in both rivers in Chile. The concentration was on the order of 10 to 12 or 14 nanograms per gram. And we're always higher in male rather than in female. That's quite interesting because females are spawning, so they are lifting a lot of eggs and pollutants transported with these eggs here. This is the BD pattern we found here. It's pretty, the PCBs concentrations in both rivers. We found more or less the same pattern. There is some difference in like PCBs concentration, but the pattern seems to be more or less the same. There's a clear domination of light congeners from Pinta to tri PCBs. And in the case of PDs also, we observe in these fish that predominating PDs are those of lower molecular weight. That may be reasonable because they are feeding in PD faraway areas from where the pollution sources may be originating more heavier congeners. When we look at the levels that we find out here, we are more or less in the same magnitude order than other authors have found in the remote ecosystems such as in Alaska or in Oregon in northern U.S. And in the case of PDDEs, our concentrations are much lower and comparable to those found in Oregon. And in this paper, we realized that people used to compare concentration from different salmon species. So even in these classic papers, people compare Chinook, Pacific salmon, Atlantic salmon, and we found that this is a big mistake. This is a big mistake. You should compare the same species and not inter-specific comparison. Moving on PCBs and salmonids, we do some analysis on culture fish and contrast this culture fish against this fish that we capture in the river. And we find pretty interesting difference here. This is coho, salmon coho, that we take out from a fish farm, and this is a salmon coho that we found in the rill. And the same with rainbow trout. We took trout culture in the fish farm, and we took trout culture sample in the rill. In both cases, levels are higher in the farmed fish. In the case of PDs, however, we found a somehow different pattern. This is farmed fish, coho wild, coho cultured, so PDs are higher in the culture. But in the trout, the opposite. The cultured trout shows lower levels than the trout we found in the rill. So we tried to figure out why this happened. And we turned out that most of the fish were actually escaping fish. How we did that? We do a staxanthin analysis in the tissue. A staxanthin is a pigment that is added in the feed. So artificial for the salmon looks great for you consumers. Yeah? And we use a staxanthin still levels. And we find very interesting difference between whale fish, scaled fish, and actually farmed fish. So statistically, with a power analysis, we can find difference. So we realized later that some of these whale trout were not actually whale, but scaled. And when the fish escape from the farm, what happened actually is that they are scared, they are stressed because they were used to feed. I mean, they were not able to look for food. They are feeded. I mean, they know that 3 times a day they are feeded, so they are used to that. In this case, when a fish escape, they are stressed, and we think that this promotes a kind of bioconcentration process. Yeah, because of lipid depletion, because of the stress. So these are more or less the pattern of PCVs that we found in the different species. Wild culture, there's some difference between both. Here we have the trout. We also find some difference between this actually cultured trout and those in the world. So pretty interesting results. And we compare obviously our results from other study. This is the PCVs comparison. Here are our levels, and we are more or less in the same range that colleagues have found for the Alaskan coho, in this case, wild. So we have 2 processes then running together. We have this natural process transporting pollutants, but we have also measured that because we have this deposition rates, and we have found that probably the atmospheric deposition costs about grams of PCBs deposit in this lake ecosystem. But looking at the amount of pollutant that may be transported by fish, we may reach the order of kilograms. So we have a natural process, atmospheric deposition, being grams of pollution, but probably we will have this fish biotransport, which is mediated by anthropogenic process because of fish farming, escaping salmons, and bad management of fish farms, etc. That could bring a lot of pollution to those rivers and lakes in such remote areas. So we were really interested in continuing to work, and we decided to move farther south in the southern end. And we decided to go to the Antarctic then to look at pollution. And there, most of the Antarctic projects are done in the Chilean isolate. And we were lucky because we were working on the peninsula Antarctica, because Chile has an army base there, and we were to go there and to take some samples in this army base there. So we went there in 2008, and we back in 2009, and we will go again now. We took some sediment samples, and we started to look at what happened in the biotic component. We look at our friends, which is not so friendly, penguins, also atmospheric samples, and some abiotic matrices like ice, snow, or even water. So we started, we took water samples, we did a solid phase extraction there, and we bring this cartridge to the lab and analyze PCBs. And we were really surprised when we started to analyze the samples because we found a pretty initial pattern of PCBs. This is ice samples taken at 1.6 meter deep. Yeah. So we found this pretty light congeners concentration that may be reasonable. If you look at the far remote south, these more surface areas. So again, light congeners. Seawater around the army base there, the we also observe some light congeners. And this is more or less the typical composition in Antarctic snow. So we have di, PCVs, tri, tetra, penta, hexa, and hepta. So clearly, light congeners dominated pattern of PCVs in that area. Some work that appeared in 2008 by Choi et al. Showed that air samplers taken in the Korean station in the Isla de Jorge in the Shetland Island found a pretty similar air pattern. This is air. The other samples were so samples enriched in pretty di, tri, tetra PCBs in that area. And they say in the paper, the Chilean Air Force base on the Iceland also considered an important pollution source. As a result, it's possible that the PCBs at the Korean station may have been affected not only by long-range transport, but also by local emissions. From Barra, they did a trace air mass back trajectory. And if you look at this, there's a pretty nice relationship with the southern cone of this continent. So they have some eastern western lights from here, but also coming from this area. When we look at the levels that we found in these samples, we have a comparison here. We have some snow levels in the Andes, in Sierra Leone, in the Andes in Chile, in different parts of the world. And the Antarctic samples are out of this scale because we have here about 3 to nanograms per liter. During the sampling, we decided to take some penguin feces. We were not allowed to take any kind of sample that could damage the penguins. So we were thinking, and we decided to take feces. It's not very nice, but at the end, I think it's pretty useful. We have 3 main species of penguins of the Feces genus that represent more or less the 70% of the aquatic bird biomass in the area. So we have the Feces adelia, Feces antarctica, and Feces papua. These penguins have differential properties. So Feces adelia has 60 to 70 centimeters. The largest one is the papua. The diet is somewhere different. We have this Feces adelia that eat krill, which is a major crustacean there, and fish and zooplankton. Barbijo, or Feces antarctica, that eat mostly krill, and papua that eat everything, mainly fish, krill, crustaceans, and whatever they can find. Some previous studies looking at the feeding range of these penguins, where the Feces adelia will move around 50 kilometers. Feces antarctica will move about 30 kilometers for feeding, and papua, which is more local themes, will move around 26 kilometers for feeding. There's not much information about migratory antecedent of this species, but we know that Feces adelia could migrate up to 1,700 kilometers. Antarctica from 1,300 to 3,600 kilometers, and for Papua it's not determined yet. So we took the samples from these 3 species and we looked for different, and we find pretty interesting patterns of pesticide in the feces, HCB, alpha, delta, beta, heptachlor, para TDE, HOP, TDT, trin, etc. But more interestingly, we find pretty nice differences in PCV's concentration between these 3 species. So Barbijo is in red, Adelia is in blue, and Papua is in green, and always Papua chose the higher levels of PCBs in the feces. Variability was not so large, surprisingly, and we decided then to sent some samples to our friends for measuring stable isotope. Try to look if they are eating differently, and thanking Krishna for their pretty interesting talk. And we found pretty nice difference between delta carbon 13 and delta nitrogen 15 between these three species. It seems that Papua had a higher trophic level that agrees with the literature information, and Berbijo, who present the lower levels of PCVs and Feces, presents the lower trophic level compared to the other two species. So we may go to the conclusions now. My impression is there, where mines go, brings pollution. Where we go, we bring some pollutants with us. It's something that we cannot. And this seems be particularly true in the Patagonia, Antarctica. Source could in most cases trace back to regional or even local sources. So fish farming for sure is a source for pollution in lakes and rivers in Patagonia. Farther south in Antarctic, Congener pattern dominated by light congener, indicating potential transport from long distance. Nearby source seems to be the southern corner of America. So we are thinking that probably one continent is also contributing to, somehow, to the pollution in the Antarctic. Decibel levels in Antarctic are higher than those observed from the Andes, which is quite surprising. In the case of Patagonian fish, PCVs are always higher than PVD is. Windborne fish present lower concentrations than the same fish sample in aquaculture centers. PCVs and PVDs profile similar in culture, and somehow will fetch. We suspect that this is because we sample actually escaped fish. And estimations are in the order of gram from the folic deposition and maybe kilograms for biotransport in some specific lakes and rivers in Patagonia. I'd like to finish thanking a lot of people who are contributing with this. This is my research group, Monica, Paulina, which is now in Canada, Ignacio, Gonzalo, Gustavo, some funding from our National Science Foundation, our National Antarctic Institute, the Mount Sinai School that provides the South-South Cooperative Project with Joao, and the UNEP, the United Nations.
I would like to know if there is some studies searching for biomonitoring using plants for the air quality. Associated with your fish studies, if there is some
study with light lichens
or
plants. Yeah, we have done already that. In previous year, we have already published some papers looking at these levels in lichens and mosses in the air, and I think that they reflect quite well the information that we are gathering now with these passive samples. So they are really comparable in terms of levels that we are detecting in this far remote areas.
So in your opinion, it's best to use passive air sampling instead of plants?
There is an issue of comparability. When you are monitoring, and in this case, we are trying to provide this data for some decision makers in the Stockholm Convention. So you need comparability. And unfortunately, biological material sometimes can provide you some comparisons, because you have differences in lipid levels, you have difference in metabolism, you have different exposure sites, so you have a lot of interpretation problems. But anyway, I would suggest to do that, because this is the actual exposure that these organisms are having, being exposed to these pollutants in the environment. So this is the truth, you know. So I would recommend to do both, and I think that never is enough to do monitoring. I mean, whatever tools you can use and that can provide different lines of evidence that you can take better decisions is much better.
The limit is the money. Thank you.
Well, you know, we are now starting a South American network for using XAB samplers. We already started last year, and we got money from the CMP group for doing that. And thanks to Brazil, we will have information for the next 3 or 4 years in different countries, in Colombia, Venezuela, Chile, Argentina, Uruguay, even Bolivia, Peru.
Interesting data. Do you have data in organic compounds?
No. Unfortunately, we have no such information. But I know that there's several people studying organic compounds in coastal areas, such as Ricardo Rios is doing complete monitoring of coastal areas, looking for this kind of pollutant. He's asking me for getting some, so I will provide this.
Do you think they should be included in the Stockholm Convention?
It's complex. It's complex. Any chemical will be included if proposed by a party. So if you think that your chemical fits with pop definition, and you have some enough and robust data for that, your country, Brazil, will go to the conference on the party and say, well, we as Brazil want to be the tributary state should be included as chemical. A good example for that is Mexico. Mexico push for getting methane and their metabolites included in the convention. So it's the only case I know from a developing country promoting a global ban for a chemical. So if you feel that we have enough robust information for doing that, you can go there. And the Stockholm Convention has an advisory body called Pollutants that analyze all this information and take some decisions, suggestions, recommendations to the conference on the party regarding to include or not your chemical in the list.
I have one question and one comment. Let me start with the comment, please. We have analyzed in our laboratory a large number of fish samples, fish meal samples, and fish oil samples. And always the samples coming from the southern hemisphere are much lower contaminated, for example, for dioxins, for PCBs, and for PBDEs. This is true, if I remember right, for fish meal as well and for fish oil. So fish oil sometimes is low if it comes from the northern hemisphere, if it is treated, but if it is normal fish oil, then it's much higher by a factor of 5 or 10 compared to the fish and all the material coming from the southern hemisphere. So that's a very clear, we have many data for that. I can easily provide that if you would like.
That's absolutely true.
Yeah.
The southern hemisphere, we have published even review of that. The southern hemisphere is less polluted.
Yeah.
So the problem is that we follow the same development that you guys did in the northern hemisphere. We are going in the wrong direction. We're getting higher levels of pollution. So I think that we have the opportunity now to keep the levels low if we want. We take intelligent decisions.
I think it would be very interesting for you to have some information on time trends, if there's any possibility. Is there any storage of, for example, of salmon, which you have in a bank, in an environmental bank or something like that, so that it is possible to analyze all the samples to see what kind of development?
This will be a really interesting idea for developing countries.
Yeah.
You know, we are now, to my knowledge, there are no data or sample banks in this part of the world. And we should do that. Because we can trace back again and look for all samples for looking for emerging chemicals in the future. But I think that for people that support this kind of initiative, this is not quite interesting, and maybe there is another urgent needs that need more funding than this. But I think that we need to promote the sample data bank in this part of the world.
Let me just now put the question. I saw your data for PBDEs, which you presented here. And I realized that the highest neutrino was 154. Do you have any data for 183 and even more important for the DECA? Because DECA becomes more and more important in the last year.
DECA is becoming more and more important, but unfortunately, when we did the analysis, the methods were not proper for DECA.
Yeah.
Now we had some injection, there's some technical. So we analyzed these samples with the method that's not allowed to look for DECA.
Yeah.
Can I say something in reaction? What do you think that the reason for the higher concentrations in the southern hemisphere is because of the difficulty for air to pass from the north to the south? Because I have some anecdote from the 1970 when I was working in a nuclear research station, and it was a few years after the big atomic bomb from the Russians, and then I put myself in a body scan and analyzed my concentration of cesium-137. It was relatively high, and then we had an Israeli colleague, it was already lower, and someone from Australia, it was 0. So it simply didn't pass is it true also, you think, because then it would be easy to explain, because the major part of the world population lives in the northern hemisphere. And also most of the production of this.
My impression is that there are two major reasons for that. One is that interhemispheric mixture takes 1 year, more or less, period. Mixture northern air mass with southern mass. So there is an issue in that. I mean, northern air mass are usually more polluted than southern mass. That's absolutely true and confirmed with many studies. The other reason is that the amount of sources that we found in the southern hemisphere is less. The sources. So that's why I think that we are fortunate in some way. We are not developed, but we have the opportunity to have less pollution. So this is a way of thinking for students. You need to think about that in this direction.
Hello, Ricardo. Very nice talk. I would like to know how's the situation of use of endosulfan in Chile, because we saw high concentrations in your study of endosulfan in the atmosphere.
Good question. I was nominated by my government to be part of the POPs review committee, but my opinions within the POPs review committee are on behalf of my expertise, not on behalf of my government. So sometimes my opinion may be different from what my government thinks about that. So the next week I will have a meeting with our Ministry of Agriculture because they have to take a decision on endosulfan. Brazil already took a decision in 2014, the total banning of endosulfan uses in Brazil, which is a large producer but also consumer of endosulfan in the soy area. In my country, the situation is different. They think that they can forbid it without a major economic cost. So probably we will have some claims from the industry side saying, well, we are banning a chemical, but it is used, but it's not widely used. But however, we find everywhere in the environment. So my impression that we'll take the decision to ban endosulfan, but probably if somewhere or someone demonstrate that there are key use of the product that cannot be replaced, they probably allow some extensions to that banning. So I think that most of the countries around the world are banning the endosulfan use. Myself think that endosulfan has POPs properties and should be banned, of course.
Why you didn't find PCBs before the 90s?
We think that the levels should be very, very low. Maybe there are PCBs there, but the levels are below the detection limits, which actually are very low, but we were not able to detect. And the other reason maybe that in this region was the only region in Chile where PCBs were never used. So we did an inventory in Chile, and in this region in Patagonia, when we take the samples, PCBs were never used. That's a very good study area because there were no materials around the world that you could find where PCBs were not used. So all the PCBs we found sure came external source. So the other thing, the other reason is that starting in the 90s, a highway was constructed in Patagonia. So the dictatorship of Pinochet, you know, military things in a different way. They were living on a strategy, and they were fighting like you Brazilians. And they built a highway called Carretera Austral, which is pretty nice and pretty good. But this allows that people starting to colonize pretty remote areas, and they promote the colonization of such remote areas. So in the 90s, actually started a colonization process pretty strong, and the industrial activities were started as well. So I think all the mixture of this caused that we started to look at during this period more or less to this pollution levels.
It's also rather a comment. So you find a very particular PCB pattern in the Antarctica. Yeah. And I very much wonder about that, yeah, because when you look, you have produced PCB 2 million tons, the normal PCB, and if you then in the Antarctica would find another pattern, this would mean that you would have somewhere a huge production of something which have a completely different pattern. Yeah. So I would rather suspect this kind of pattern can be found, for example, in pigments, yeah, in color pigments. And when I look, this is your station, or this one, the red station. I would one time analyze this paint. Paint is one thing. Also, when you look to the paper of the Koreans, they have the same red station. Yeah. Yes. And then another source for it are printers. Yeah. In printers also you have colors, and actually you find in these paints, especially these low, the dichlorinated and trichlorinated, and also you find very high chlorinated. So I saw this 191. So this would be one thing what would be very interesting to investigate.
Another major source may be illegal waste disposal in the southern cone. You know, we find very high levels. We've published that many years ago, very high levels of PCBs in bivalves, in mussels, in the southern part of Chile. And we were really strange because the use of PCBs, there were some use there, but clearly more autochlor stuff, and then we find this. And I was thinking that, I don't know, this is a Magellan Strait there. You know? I don't know.
You
are more familiar
you
with
also
this.
need a waste with this PCB pattern, yeah, and this PCB pattern seems for me very similar
to the painting.
To paintings.
Yes.
Yes.